Hello everyone, this is Sharyan Soni, student ID 253777738, and this is my demo for assignment 1 of CS7GV03 real-time rendering. In this video, I will demonstrate and compare multiple reflectance models implemented using GLSL vertex and fragment shaders. So without any further ado, let me compile and run the program so that we can see all the multiple shaders. As you can see in this scene, we have multiple instances of the same model, each rendered with a different shading model. All models rotate continuously and share the same camera and light source. Let me go to the first model that we are discussing, Phong shading model. A Phong shading model is an empirical lighting model composed of ambient, diffuse, and specular components. The diffuse term is based on Lambertian reflectance. I have also added UI controls that allow the diffuse term to be zero. With diffusion disabled, the model will start to appear with only the specular highlights. So let me change that. I do that. If you can see that the model only have specular highlights. And if I increase this again, you see that it is back to looking like it was earlier. But if I decrease the specular strength this time, we'll see that it looks like a matte object now, and it resembles very closely to the Lambertian shading model that I have also implemented. The specular strength essentially controls the intensity of how strong the specular lighting should be. You can see here, if I increase it, you can see the area increase in the area. Let me also stop the rotation. You can see how much the intensity increases, whereas the shininess factor, which is, if you see here, is part of the specular uh, variable. This controls the size of the reflectance of the reflection we are getting. So if we increase it, it gets tighter and tighter, and we get high shininess, but the size reduces because the shininess is increasing of the object. The one problem with Phong shading model is at grazing angles, it is unable to perform correctly. So let me show you at grazing angles. Now I will also move the light source to be completely behind the model. Yeah. You see here, if you see these, this is where at grazing angles, the Phong shading does not correctly model the increased reflectivity. Okay, so let me put the shade light back to where it was, that we can go to different models. The next model that we have is the Toon model, which is a non-photorealistic model. We start rotating the models again so we can see how it reacts to light in different conditions. I'll also move the light a little bit closer so that you can see what is happening here. Yeah. If you see here, we can see that in a two shading basically tries to quantize the light into discrete bands. So I will take you to the tone shading. Here, if you see, we have the difference, which is quantizing the lights into different bands depending upon how many levels are there. And we can also change the number of levels through the UI. So if I decrease this, you can see it is reducing the number of levels for it. I will also go and stop the rotation for a second and then show how it looks like. If you see, if I increase the bands, you have multiple bands, but if I decrease the number of bands, it will start to look a little bit smoother. And increase, it will start to look with more bands, it will look closer to few real objects, but it will still have that cartoonish feeling with these bands. But if I decrease it, if you will see that it will have only maybe two bands here. So you can see that only two bands are being shown and the highlights are pretty high and it looks even less realistic here. Now, Finally, we go to a physics-based rendering model for the Cook tolerance, and this uses the microfacet theory to model realistic light interaction. In here, the through the UI, the roughness parameter controls the speed of reflections, the spread of reflections. So if I were to stop this and go close to this, you can see if I increase the roughness, it will start to resemble a matte looking object because the roughness should increase the spread of these reflections and essentially make sure the reflections are less specular in nature. Similarly, the metallic nature will essentially in makes the reflection behave like metal or dielectric. So the model essentially will be reflecting either the color of the light or the reflection will resemble the color of the model. If you see here closely, now it is reflecting a much darker red color, and at this point it is reflecting white color. And this is the difference that makes it look like more like a metal, or this is more closer to a glossy plastic object. This is my project. Thank you for listening in.